All right, we're going to be combining a bunch of the different concepts that we've done so far this unit in order to complete two-step problems for related mole calculations. So there's three different relationships that we've learned about back in concept B and yesterday in the previous concept. Basically, we can relate all of these to a mole. So 1 mole is equal to the GFM of a particle. 1 mole is equal to 22.4 liters of a gas. And 1 mole is equal to 6.02 times 10 to the 23rd particles of a gas. So any of these relationships we can represent with an equality. If we know any of these, we can find the rest. Each arrow represents an equality or conversion factor. If we go through 2 arrows, like today we're going to be doing, then we need 2 equalities. In each of these 2 sets of problems, we're going to be converting to moles first. So how many molecules are contained in 34.0 grams of ammonia? So the way that this word problem is different than what we've seen before is, before we were always going where either one of them starting with moles or ending with moles. Now that's going to be our middle grounds. So in this case, we're going to be going from our grams, so mass, to moles, then to our number of particles. So 2 equalities are needed. So as always, we're going to start with our given. Okay, then we're going to go ahead. We have our grams that is going to be in the first denominator, just like always. So this is where we're going to convert from mass to moles. So I have grams of NH3 going to moles of NH3. Our GFM, which you would calculate, is 17.0 grams of NH3, and that's equal to 1 mole. Okay, now these grams have canceled each other out. So now we're going to go from moles to the number of particles. So here we know that a mole of NH3 we can relate to the number of particles or molecules specifically of NH3. And we know that that equality is that 1 mole of NH3 is equal to 6.02 times 10 to the 23rd molecules of NH3. So as you see, we've gone from grams and then converted from grams to moles and then moles to molecules using the 2 equalities. So we can cancel out our repeating units, leaving us with our desired or target unit, which is molecules of NH3. We would then go ahead and multiply across the top and divide by anything on the bottom. So we are left with molecules of NH3, specifically 1.2 times 10 to the 24th molecules of NH3. All right, how many grams of krypton does it take to fill a 3.4 liter balloon at STP? Again, neither of these are moles, and we're talking about the same substance. So we know then that we have to go from our volume, which is our given, to moles, to the number of grams, or our mass. We need 2 equalities. So we're going to again start with what we're given, 3.4 liters of krypton. We then know that we're going to use this next equality to go from volume to moles, specifically making sure that if I'm starting with liters in the numerator, I need to put liters in my denominator and then relate that to the moles of krypton. We know from our previous unit, our concept, that 2.4 liters of a gas is equal to 1 mole of a gas. And then moving ahead, we can now go and convert from moles to mass. We know that we can relate moles to the GFM of krypton. We know that 1 mole of krypton is equal to its GFM, which is 83.9 grams of krypton. We can cancel out our repeating units in the numerator and denominator, which includes our liters units and the moles, so we're left with our target unit of grams. We then multiply across the top, divide by the 22.4 on the bottom, and you should end up with 12.7 grams of krypton. All right, and finally, we're going now from molecules or particles of a gas to how much space, meaning volume. So we're going to go from particles to mole to volume, so we need 2 equalities in order to get there. So again, starting with what we're given, and then we're going to go ahead and write out our first equality that is going to take us from particles to moles, that relationship, which is 6.02 times 10 to the 23rd molecules of F2, which is equal to 1 mole of fluorine. Our next equality then is going to take us from moles, because remember, if I were to calculate this as is, my unit would be moles. However, I want how much space or volume. So that's why I need to use the second conversion factor in order to get to volume. So we know then that 1 mole of F2 is equal to 22.4 liters of fluorine. All right, we can then cancel out our repeating units, which gets rid of the molecules in the numerator and denominator and moles in the numerator and denominator. So we're left with our desired or target unit of liters of fluorine. We then multiply across the top and then divide by the 6.02 times 10 to the 23rd, and our answer is 0.05 liters of fluorine will be occupied when we have 1.22 times 10 to the 21st molecules of fluorine present. All right, so if in your summary, I would just basically go over those 3 relationships that we're going to be applying in these two-step problems, and also a general idea of what are the big points of reminders to yourself of how to set those up correctly when you go to do dimensional analysis.